Hello everyone, welcome to IDL Project PhonemeLM, phoneme-centric correction for accented speech recognition. Imagine you're trying to call your bank to cancel an important time-sensitive transaction, and your bank has a speech recognition system to answer customer queries. Maybe you're not a native English speaker, and the system continuously denies your request. This brings us to the problem we are trying to solve, that traditional ASR systems struggle to capture different pronunciations due to their limited ability to learn different speech patterns. Now, how exactly do most traditional ASR systems work? We give an input audio and they do some pre-processing and using some language models capture word sequences. Now let's take a look at this at a phoneme level. A phoneme is the smallest unit of sound in a language that can distinguish words from each other. As we can see, traditional ASR fail to capture some of the distinct pronunciations depending on the accents that the speakers use. In a more constructive way, if we look at the problem, these are some of the issues working with accented speech which traditional ASR models fail to solve. So far, phonetic modeling within ASR has had limited research, indicating a significant potential for further exploration.
Now let me give you more insights into what we are actually doing here. So after looking at the traditional ASR architecture, a caveat we focused on here was, can the ASR model work well even if the audio has different accents? The answer is not always. So in order to tackle the accented difference, we focus on the phonemes and introduced a phoneme-based language model called PhonemeLM. By leveraging phoneme-based language modeling technique, we transcend the challenges posed by different spoken accents, offering a transcription accuracy that truly bridges linguistic gaps by focusing on phonemes as the fundamental speech units that ensures adaptability across different linguistic contexts. Now let's talk about the model that we use for converting speech audio to phonetics, the Facebook developed Wave2Vec 2.0, which is fine-tuned on a staggering 53,000 hours of audio. It effortlessly transcends language boundaries by converting the spoken words into rich phonetic interpretation. Now let's talk about the other integral piece of a language puzzle, the grapheme to phoneme conversion. This model generates the pronunciation of words based on their written forms, and we employ G2PE module, which is a user-friendly tool leveraging the CMU pronouncing dictionary. Coming to datasets, during the pre-training phase, we use the rich LibriSpeech dataset, which is a collection of over 1000 English speech hours. And for fine-tuning, we use a VCTK dataset, which comprises over 45 plus hours of speech from 110 speakers with diverse English accents.
Our project is divided into two phases, pre-training and fine-tuning. During the pre-training phase, we utilized the LibriSpeech dataset. Initially, we employed the G2P model to convert the text transcriptions into phonemes. Subsequently, we cleaned the phonemes generated by the G2P model, a process that involved the elimination of punctuation and stress markers. We then used a phoneme encoder to generate token embeddings, to which we added positional embeddings as well. Finally, we trained our PhonemeLM model using these embeddings. Let's look at the architecture of our proposed attention-based language model, which we call as the PhonemeLM. The input phoneme sequence is encoded as fixed-size token embeddings. Additionally, we incorporated positional embeddings to include contextual information based on their positions. These embeddings are passed through 4 transformer encoder blocks containing multi-headed attention to capture the complex language patterns. Finally, a feed-forward neural network followed by a softmax layer is used to generate the probability distribution across the phoneme vocab, showing likelihood of each phoneme. In the fine-tuning phase, our aim is to fine-tune our model to correct the ASR's output for accented speech. We employ the VCTK dataset for this purpose. We use the fine-tuned Wave2Vec to ASR model to transform the VCTK audio files into IPA tokens. These tokens are then converted into phonemes using the alphabet dictionary. Following this, we perform the same pre-processing and encoding on these phonemes. This serves as our input training data. On the other hand, we transform the VCTK transcripts into phonemes using the G2P model, followed by pre-processing to obtain our ground truth data. Finally, we fine-tune our PhonemeLM model using this training data and ground truth and conduct a loss analysis. In this analysis, we employ metrics like phoneme error rate, Levenstein distance, and BLEU score to evaluate the performance of our model.
Now let's delve into our findings. We have developed a specialized attention-based architecture for our phoneme language model, which is optimized to process the phonemic inputs. We have also built a training pipeline that helps our model capture robust language representations effectively. After training our model for 5,000 iterations, our model achieved a validation loss of 1.8, indicating its strong predictive capabilities. Here on the right, you can see an example where we input a phonemic sequence and our model generates a few next possible phonemes. In the future, we plan to use phonemic logits. With the ASR, generating the phonemic data for audio files using logits permits the model to have a wider view of phoneme probability distributions, capturing patterns and uncertainty effectively. In conclusion, we have developed a phoneme dataset for ASR applications and designed a PhonemeLM architecture tailored for phonemic inputs by building a robust training pipeline to empower PhonemeLM in learning nuanced language representations. We have initiated fine-tuning to enhance PhonemeLM's accuracy in transcribing diverse accents within English speech. To wrap up, the outcomes presented today mark the beginning of a broader conversation in the field of accented speech recognition with phoneme-based LLMs, encouraging discovery. Thank you. We look forward to answering your questions.